Hi class. So for these functions, we're going to learn the chain rule. And the chain rule is the most important rule of a derivative. Just like the other rules, you're going to have to memorize it really well. This is not it's not about memorization for the chain rule, because what we have to do is take care of something like the composite function. So you need to be able to recognize the inner function and the outer function. Now, the chain rule, it goes like you have to take care of the outer, and then you multiply by the derivative of the inner. So you see number one right here. It's important for you to recognize the outer and the inner. So hopefully you can recognize that the outer function is the square root function. And of course I have to rewrite the function, so I can use power rule. Okay, so I'm going to take care of the power rule, which is 1/2 x squared plus 1 to the negative 1/2. And then we're going to take the derivative of the inner, which is derivative of x squared plus 1. So I'm just going to rewrite 1/2 x squared plus 1 to the negative 1/2. The derivative is going to be 2x. And then you can just simplify it. Okay. So what I have is x in the numerator, and the denominator is the square root of x squared plus 1. That's the chain rule. Okay, so moving on to the next function. Hopefully you see the difference here. You see a, we have to take the derivative of sine of x squared, and b, we have to take the derivative of sine square of x. So what is the inner and what is the outer? So for part A, the outer function is going to be the trig function, the sine function. So if I want to take the derivative of sine is cosine of x squared, and then you multiply by the derivative of the inner function, which is 2x. And there you have it. Now, for part B, hopefully you recognize that the outer function is the square function, right? So if I want to take the derivative, I have to take care of the square, which is the power function. So 2 sine of x. And then we're going to multiply by the derivative of sine of x, which is cosine of x. So what I have is 2 sine of x cosine of x. And that's how we proceed with the problem. Now you can see that we cannot simplify this one. If you want to rewrite and you want to put the 2x in front of cosine, that's fine too. All right, now moving on to example 3. So you see that the 100, the power 100, that's going to be the outer function. So first, I take care of that, 99, right? And then I take the derivative of x cubed minus 1, which is 3x squared. So what I have is 100 x cubed minus 1 to the 99, and then 3x squared. Okay. All right, the only thing I can multiply, I can simplify, is that's constant right there. And then so we have 300. I can put x squared, and then we have x cubed minus 1 to the 99. Okay. All right, moving on. So that's going to be your final answer. Moving on to the next example. What I have right here, of course, finding the derivative. So hopefully you recognize that the cube root is the outer function. But first, let's rewrite the f function. So if I want to rewrite, that would be x squared plus x plus 1 to the negative 1/3. Okay, so from there, we're going to take the derivative. So the derivative of the outside is going to be negative 1/3 x squared plus x plus 1. And then you have to subtract 1. So negative 1/3 minus 1. So you know what? I'm just going to write it down for you so you understand what I'm doing. There, minus 1. So I have to do the whole LCD. And then we're going to take the derivative of the inner function, which is x squared plus x plus 1. So what we have is negative 1/3 x squared plus x plus 1 to the negative 4/3. And then the derivative of this one is going to be 2x plus 1. Okay, and then once again, you can rewrite. I have negative. I'm going to put 2x plus 1. And then on the bottom, we have x squared plus x plus 1 to the 4/3. Okay. All right, moving on. Okay, so you can see that we have the quotient rule, right? And we have the power rule, which is the ninth, the ninth power right here, the exponents. So we're gonna go ahead and proceed the outer, and then we're gonna go and do the inner. So the outer is 9 t minus 2 over 2x. I'm sorry, this is supposed to be 2t. Otherwise, we treat it as a constant. Plus 1 equals to 8. And then we have to take the derivative of the inside, which is t minus 2 over 2t plus 1. Okay, so once again, the inside is the quotient rule. So hopefully you still remember how to take care of quotient. How about I just write it up here? So it's going to be f prime g minus f g prime over g squared. Okay, so I'm just going to rewrite the first part 2t plus 1 to the 8th. Now, let's take care of the derivative inside. So what we have is 1 times 2t plus 1, and then minus t minus 2, and then 2t plus 1, you take derivative, it would be t. And then we have 2t plus 1 squared. All right, what I need to do right now is I need to simplify it. So what I have for this one, I can't really simplify this one. So I'm just going to keep it that way. And now the inside. So what do we have here? We have 2t plus 1 minus 2t plus 4 over 2t plus 1 squared. So what I have is 5. Okay, so 5 over 2t plus 1 squared. But we have this one, you can just make it t minus 2 squared over 2t plus 1 squared. This one we have 5. And then on the bottom I have 2t plus 1. Okay, so I'm going to multiply 9 times 5, which is 45. And then I have t minus 2 squared over, and on the bottom, I'm so sorry, it's supposed to be 8. It's supposed to be 8. So on the bottom, I have 8 plus 2, so that's 10. And that's my final answer. Okay, moving on. Example 6. So what we have right here is just simply product rule, right? So for product rule, it's actually easier than quotient rule. So I'm just going to put f prime g plus f g prime like that. Okay. It's really doesn't matter what the order is because we have addition. Okay. So let's take care of f prime. So you can see that this one right here is f, this one right here is g. Okay, so f prime gives me 5, 2x plus 1 to the 4th. Okay, and then inside times 2. So that's the derivative of f prime, of f, which is f prime, multiplied by g. Okay, plus f is 2x plus 1 to the 5th power. Now we take care of the g. So g is 4x cubed minus x plus 2 to the 3rd power, and chain rule, so I have 3x squared minus 1. Okay, let me just rewrite for you. So this whole thing is f prime, this is g, this is f, and this whole thing is g prime. Okay, so now we just have to simplify it. Actually, the only thing I can do is I can just multiply this. If you want to factor it out, that's okay too, but I don't think we have to. I'm going to bring the 4 to the front. Yeah, like I said, you can always factor it out or you can just leave it that way. All right, moving on to example 7. So example 7, you see that the outer function is the e function and the inner function is the sine function. The inner function is the sine function. Okay, all right, so let's just take care of y prime. E function, the derivative is just e itself. And then we multiply by the derivative of sine, which is cosine. Okay, and you can just leave it like that because we can't really simplify it. Okay. All right, let's take care of the log function with chain rule. So you see that if we have the derivative of b to the x power, it's going to be itself, b to the x power, just like the e function, and then you have to multiply by ln b. Okay, now check this out. You see we have sine of cosine of tangent. So we have 3 different functions, so you're going to have to take care one by one. Okay, so first, the outer function is the sine function, so we ended up with cosine. of tangent. And then we take the derivative of the inner, which is cosine of tangent. Okay, which is what? Which is negative sine tangent of x. And then you have to take the derivative of the inner, which is tangent of x. So I have to rewrite everything. Multiply by the derivative of tangent of x is secant square. Okay, let's just bring the negative outside. So what we have is negative cosine of tangent multiply by sine of tangent multiply of secant square. Okay, I know it's a lot of work because we have three different functions. Okay, all right, let's take care of example 9. So example 9, you see that we also have three functions, so hopefully you recognize that. The outer function, the first function is the e function. The second function is the secant function. I'm going to put v. And then the third function is just simply that. Okay? All right, so what can we do? We're going to take the derivative. First of all, the derivative of e function is just e function. And then multiply by the derivative of secant, which is secant tangent. And then you have to multiply by the derivative of 3 theta, which is just 3. So e secant 3 theta, secant 3 theta, tangent 3 theta, multiplied by 3. Okay, and then you can just simply bring the 3 to the front to make it look nice. And that's our final answer.